In this video, we are continuing with Chapter 4. This is Chapter 4, Section 6, Maps and Scale Drawings. What you'll learn in this video is to use proportions to solve problems involving scale. The two terms you'll be defining in this video are scale drawing and scale. When you see them defined in the video, be sure to pause the video and write down the definition in your notebook. A scale drawing is an enlarged or reduced drawing of an object that is similar to an actual object. A scale is a ratio that compares the length in a drawing or model to the corresponding length in the actual object. So if a 15-foot boat is only 1 inch long in a drawing, you can write the scale of the drawing in these three ways. 1 inch to 15 feet, 1 inch over 15 feet, or 1 inch equals 15 feet. So let's look at an example. We're going to be an example of using a scale drawing. So the length of a side of a house is 3 centimeters on a scale drawing. What is the actual length of the side of the house? So we have our scale written here for our drawing. So it says 1 centimeter equals 2.5 meters. So we can use that to write that as a proportion, or as a ratio. You can write the scale of the drawing as 1 centimeter over 2.5 meters. Then write a proportion with the 3 centimeters we know and the amount we don't know that we're looking for, which is the actual length of the side of the house. So our scale proportion down here, we're using to create this proportion. Then we're using the 3 centimeters and what we don't know to make our second ratio to form our proportion. Now, if we do cross products, we end up with 1n equals 2.5 times 3, which gets us 7.5, because we know when a variable is by itself, the 1 is implied, so we don't have to write that when we work through our equation. And then 2.5 times 3 gives us 7.5. So the actual length of the side of the house is 7.5 meters. It's kind of like when we were solving for a missing side in our similar figures, but instead of using the sides of the similar figures to create our proportions, we're using the measurements given to us in the scale. Pause the video and try these two in your notebook. Be sure to number the problems and write down all the important information. Show all your work, do not just write an answer. You can use the greatest common factor to find the scale of a drawing or model. The greatest common factor, or GCF, is of 2 or more numbers is the greatest factor shared by all the numbers. You can find the greatest common factor of 2 numbers by listing their factors. There are 3 ways to find the greatest common factor. The first way is using lists of factors. So if you want to find the greatest common factor of 18 and 30, list the factors of 18 and the factors of 30, then circle the common factors. So the factors that 18 and 30 have in common are 1, 2, 3, and 6. And if you're looking for the greatest common factor, you want the highest number they have in common. So for 18 and 30, the greatest common factor is 6. The second way to find the greatest common factor is using a division ladder. You can find so we want to find the greatest common factor of 42 and 56. We use a division ladder. So you write your original numbers and think, okay, what is something I know I can divide both of these numbers by? They're both even, so I can divide them both by 2. Then you put your answers for dividing by 2 in the second line. So pretty much you're doing your division kind of upside down and seeing what numbers will go into both of the digits. So we know 7 will go into both 21 and 28, which gets us to 3 and 4. And then 3 and 4 have no common factors. So to find the greatest common factor, you take the numbers to the left of the ladder and multiply them. So 2 times 7 equals 14, so the greatest common factor of 42 and 56 is 14. The third way to find a greatest common factor is using factor trees. Say we have a volunteer divides 18 adults, 27 girls, and 36 boys into groups to clean up the park. He divides the adults, girls, and boys equally among the groups. What is the greatest possible number of groups he can make? So we'll use a factor tree to factor out 18, 27, and 36. So if we have 18, we know 18 can be factored into 9 and 2. 9 is prime, so we go ahead and circle the 2. Then 9 can be divided into 3 and 3. So 2, 3, and 3 are my prime factors of 18. Do the same thing for 27. We get 3, 3, and 3. And 36, we get 3, 3, 2, and 2. So if we write out all of our factors, they both have 3 in common. So 3 is what everybody has, so 3 times 3 gets us to 9. The greatest number of groups is 9, so the greatest common factor of 18, 27, and 36 is 9. Let's look at finding the scale of a model. For the model, refer to the model boxcar shown at the right. The actual length of a boxcar is 609 inches. What is the scale of the model? So our model is 7 inches. So our scale length is 7 inches. And our actual length is 609. So we have 7 over 609. Then we want to get the scale length down to 1 so we can get a ratio of 1 to something to figure out the scale of the model. So you divide both by 7 because that's the only way we can get 7 down to 1. So dividing 7 by 7 and 609 by 7, and we end up with 1 over 87. So our scale for the model is 1 inch to 87 inches. Pause the video and try these two in your notebook. Again, make sure you write down the numbers, write down all the important information from the problem, and show all your work. Do not just write down an answer. Let's look at another example. Say you want to make a scale model of a sailboat, which is 51 feet long and 48 feet tall. You plan to make the model 17 inches long. Which equation can you use to find x, the height of the model? So A, B, C, or D, which one of those is a correct proportion to solve for the scale to find the missing x? Well, first we're going to take the information we were given. So the model length is 17 and the actual length is 51. Then the model height in inches is what we don't know, and then the actual height in feet is 48. So this is our proportion for this problem. 17 over 51 equals x over 48. So the correct choice is B because that's the one that matches our equation, or our proportion that we've set up. Pause the video and do these two in your notebook. You can also use cross products to find a scale. The map key shows that the map distance of 1/4 inch represents the actual distance of 5.8 miles. We want to find the actual distance represented by 1 inch to write the scale of the map. Now, so our proportion that we're going to set up, we're going to have our 1/4 from our key goes here, and then our 5/8 of actual distance goes here. Then our proportion, what we're trying to find out is 1 inch, which goes there, and the amount we don't know is the distance represented by D here. So our proportion is that. Then we're going to do cross products, so 1/4 D and then 1 times 5/8 gets us our 1/4 D, and 5/8 times 1. 5/8 times 1 is just 5/8, so we have D over 4 equals 5/8. Then we're going to multiply both sides by 4 to move this 4 out from underneath the D in our equation. And that gets us D equals 2.5. So the actual distance represented by 1 inch on the map is 2.5 miles. So the scale is 1 inch to 2.5 miles. Pause the video and do these two in your notebook. Now it's time for Check Your Understanding. Be sure to write down the original problem and show all your work. Enjoy the rest of your evening, and I'll see you tomorrow.